So in the last session, we discussed the quotient rule and as well as product rule. Now we can go with a somewhat different, not different, but it is easy only. See that expression. So generally what we are writing, d by dx of x power n, d by dx of x power n. What is the differentiation of x power n with respect to x? The differentiation of x power n with respect to x is n into x to the power of n minus 1. N into x to the power of n minus 1. But also we have to take the differentiation of x only. Only x, not x power. This is the total x power n. If you are talking only x, that is d by dx of x. But generally you know that d by dx of x is nothing but 1. So that means you get n into x to the power of n minus 1 into 1. Actually, we are not writing this one because whatever you are multiplying with 1, we are getting the same value. So here we are not having the problem because the differentiable function and differentiating function both are same. In case if we have different values, d by dx of y power n, d by dx of y power n, then what is happening? Let's see here, d by dx of y power n, nothing but what we can able to write, n into y to the power of n minus 1, n into y to the power of n minus 1 into dy upon dx. So means differentiation of y with respect to x. Here also I did the differentiation of x with respect to x, but the value is 1. But this value is not possible to become 1 because differentiable function and differentiating function both are different. So now the final expression of this, n into y to the power of n minus 1 into dy by dx, dy by dx. So this is the simply dy by dx of y power n. In case if you have d by dx of y power 4, then how do we can solve? Very simple. It is look like y power n, n into y to the power of n minus 1, 4 minus 1, 3 into dy by dx. Why we are getting this dy by dx? Differentiable function, differentiating function, both are different. Take one more. If you have d by dx of y power 10, then what is the value? Simple. 10 into y to the power of 10 minus 1 into dy by dx. Why we are getting dy by dx? Again, differentiable function, differentiating function, both are different. So then you can get 10 into y power 9 into dy by dx. So where we can use this expression? Once we can try this expression in UV rule. Well, let's see. We can apply this method in UV rule. UV rule, what is that? Here one problem is given. For example, d by dx of xy square or x square y, d by dx of xy, take only xy, d by dx of xy. Very carefully you have to observe. Here x is a differentiable, x is a variable function and y also another variable function. X one variable function, y another variable function. Now how do we can apply the method of UV rule? Simple. First u into is x into dv by dx, nothing but dy by dx, x into dy by dx plus y into dy by dx of x, x into y into dy by dx of x. Means what is the value you are getting here? X differential, x is constant, u constant first we are considering, and then dy upon dx plus y into d by dx of x is 1. So simply the differentiation of x into y is x into dy by dx plus y, x into dy by dx plus y. And also generally what we are doing here, differentiable function and differentiating function both are different, and that case only we can apply it. Take one more example here. For example, you have d by dx of x square into y square. X square into y square means what we are taking here. X square into y square means x square. First you can imagine like u into d by dx of y square plus y square into d by dx of x square means u into dv by dx plus v into du by dx. See here, x square, differentiation of y square 2y, differentiation of y dy by dx. So see here, what we are taking, y power 4 into y cube into dy by dx. Here also same, y square 2y into dy by dx plus y square into differentiation of x square 2x into dx by dx, what is 1. So simply what is the simplification of this? This is the simplification of this is this much. And now we will move to some. We'll discuss some important formulas in differentiation. So see here, what are the important formulas? I'm taking here first d by d theta of sine theta means sine differentiation, sine theta differentiation with respect to theta, that is cos theta. In case if I am taking d by d theta of sine x, so please observe the difference. Differentiable function, differentiating function both are same. Differentiable function x, differentiating function is theta. So that's why first you can write sine, only sine differentiation is cos. How much? Cos x, because we are taking cos x here. And differentiation of x with respect to theta, d theta by dx. Differentiation, dx by d theta. Differentiation of x with respect to theta, dx by d theta. And second, very simple here, d by d theta of cos theta. D by d theta of cos theta. Cos theta differentiation you are getting minus sine theta into d theta by d theta. D theta by d theta means 1 only, so that's why no need to write. And take d by d theta of cos x. D by d theta of cos x, because x is another variable. So then only cos x in differentiation is minus sin x, and x differentiation with respect to theta is dx upon d theta. X differentiation with respect to theta is dx upon d theta. Next, d by d theta of tan theta. Tan theta you can get here simply secant square theta. That's all. Again d theta by d theta 1. D by d theta of tan x. Again tan x, only tan x differentiation is secant square x, and x differentiation is dx upon dt. X differentiation is dx upon d theta. Next, take one more, d by d theta of cot theta. Cot theta means minus cosecant square theta. Minus cosecant square theta. Differentiable and differentiating function both are same. If it is cot x, can you say what is the value cot x? Yes, very good. Minus cosecant square x, and x value is dx upon dt. X value is dx upon dt. Next, fifth trigonometric function, d by d theta of secant theta. Secant theta differentiation is secant theta, bonus it is getting secant theta, and again tan theta. Secant theta, tan theta. In case if you are taking d by d theta of secant x, That means you are getting, can you say the formula? Yes, secant x tan x into dx upon dt. Secant x tan x into dx upon dt. Why again dx upon dt? Differentiable function, differentiating function, both are different. Next, last trigonometric function, dy d theta of cosecant theta. Cosecant theta differentiation is minus cosecant theta into cot theta. Minus cosecant theta into cot theta. The d by dt of cosecant x is, can you say the formula? Yes, minus cosecant x cot x into dx upon dt. Minus cosecant x cot x dx upon dt. So these are the trigonometric formulas. Next, trigonometric formulas based on differentiation. Next, we will write some logarithm functions. Logarithm functions. d by dx of log x. Log x. d by dx of log x. So log x means here base a if you are taking. So then 1 by x into log a base e. Log a base e. In case if you are taking d by dx of log e base x. So that is simply 1 by x. That is simply 1 by x. In case if you have d by dx of e power x, the value is simply e power x only, no change in that exponential. In case if you have d by dx of e power u, that means simply you are getting e power u into du by dx. Why? U is another variable function. So let's we discuss one more rule, chain rule. Chain rule. What is this chain rule? Very interesting rule here. Chain rule is, for example, you have a function here. I am taking well-known function only. The acceleration a is equal to dv by dt. Acceleration a is equal to dv by dt. This how to we can write in the chain form. The chain form is nothing but I am writing dv by dt into ds upon ds. ds upon ds means multiply and divide with the ds. Is there any change? No. The value is 1 only. So now what I am doing, I am just replacing s ds to dt. Means if you are replacing that, that is goes to dv by ds into ds upon dt. dv by ds into ds upon dt. What we are doing? We are doing nothing. Just we send ds here and dt here. This is called simply chain rule. This is called simply chain rule. So this is the acceleration value. There is no change in this. So by application of this chain rule, we will try to solve one problem. See here. Here the question is, if x is equal to a t power 4 and y is equal to b t power 4. X is equal to a t power 4 and y is equal to b t power 4. Then what is the value of dy upon dx? What is the value of dy upon dx? First I am taking, this is the question, and first what I am taking here, the differentiation of x I am taking with respect to time. The differentiation of x with respect to time I am taking. What is the differentiation of x with respect to time means that we are writing d by dt of a t power 4. d by dt of a t power 4. How much you are getting? The dx by dt is equal to a constant and 4t cube. A constant and you have 4t cube. So that means dx by dt means you have 4a t cube. Similarly, you can take the differentiation of y function with respect to time. Instead, dy by dt is equal to dy dt of bt power 4. dy dt of bt power 4. So b is constant. T power 4 differentiation 4t cube into b. 4t cube into b. So that means what we can able to write? Simply dy by dt is equal to 4b t cube. dy by dt is equal to 4b t cube. But what is our requirement? Our requirement is dy by dx. So now I am going to take this chain rule. See here, dy upon dx is equal to, I am writing this expression, dy by dx into dt upon dt. Is there any change if I am doing like the dt upon dt? No change. So then you can write simply dy upon dt into dt upon dx. dy upon dt into dt upon dx. So see here, dy by dt value you know? Yes, 4b t cube. You know dt by dx? No. But you know dx upon dt means reverse. So that means what I am writing here, this expression as dy by dt upon dx upon dt. dx upon dt. So since see here how much you are getting, dy by dt is equal to 4b t cube and dx by dt is equal to 4a t cube. So then t cube 4 cancel. So then what is the dy by dx value? Is simply b by a. dy by dx value is simply b by a. And let's we can apply this expression to our physics. So generally we know that what we are considering, S stands for displacement, V stands for velocity, A stands for acceleration, T stands for time. T stands for time. Displacement, velocity, acceleration and time. So once you can comes to the displacement is nothing but the shortest distance between the 2 points and the line joining from initial to final point. Velocity is nothing but displacement upon time. So if you are writing the velocity formula, velocity you are using that expression displacement upon time. Displacement upon time. In case you require instantaneous velocity, instantaneous means at a particular instant of time, a small interval. So that instantaneous means what we are writing? V instant is equal to ds upon dt. V instant is equal to what we can able to write simply ds upon dt. Where ds means small change in displacement, dt means small change in time, small change in displacement and small change in time. So this v is equal to what we can able to write simply v is equal to ds upon dt. V is equal to ds upon dt. One important expression. And also comes to the acceleration. What is the definition of the acceleration we are using? The definition of the acceleration we are using change in velocity per unit time. Change in velocity per unit time. The change in velocity is generally what we are taking. The change in velocity we may write u minus u by t. V minus u by t. If the change is very small, so that's we are representing dv upon dt. Already I told you, whenever we are using this expression, this is also we are writing delta s upon delta t, where delta represents the large change, d represents the small change. Here also we can able to write delta v upon delta t. Delta represents the large change and d represents the small change. So this is a one more expression. So first expression v is equal to ds by dt, and second expression dv upon dt. So now we can see here how we are applying this is into our physics. And one more here, a small point is forgot we are, that is double differentiation. Double differentiation. The double differentiation now we are using in this. What is the double differentiation? Double differentiation means, for example, I am giving the value of y is equal to x power 3. You are finding dy by dx. But I am also find the next order differentiation of that. Next order differentiation, that's only called as second order differentiation. So if you are differentiating it, how much you are getting? Dy by dx. The differentiation if you are doing, how much you are getting? 3x square. If I am asking next differentiation of this, next dy by dx of 3x square. Dy by dx of 3x square means how much you can get? 3 into x square is 6x. So means actually what we did here, differentiation of the y we did, and again what we are doing, differentiation of y, differentiation of dy by dx with respect to x. This is called second order differentiation. So see here what we are taking, dy by dx. Dy by dx means this is goes to d square y upon dx square. We are taking, this is a second order differentiation. This is the first order differentiation, and this is second order differentiation. Dy by dx and d square y by dx square. So if you are second order differentiation is, again you have to differentiate the given function. What is the given function? D by dx of dy square means, what is the given function means, simply we have to take d by dx of 3x square. D by dx of 3x square. What is the value of 3x square? 3 into x square differentiation 2x. The value is 6x. So means, what is the value of this differentiation? D square y upon dx square is equal to, simply you got 6x. D square y upon dx square, we got 6x. So this is the double differentiation. Double differentiation. The double differentiation we can apply in this acceleration also. How? Generally, you know that acceleration A is equal to dv by dt. Means acceleration A is equal to d by dt of v. What is the value of v? The value of v is d by dt into ds by dt. Means nothing but d by dt or ds by dt. So that means the double order differentiation, d square s upon dt square. D square s upon dt square. So see here what we are doing, d square y upon dx square. So similarly d square s upon dt square. So first velocity ds by dt, velocity differentiation with respect to time, acceleration. Then acceleration we need in terms of displacement. Then again you have to differentiate the differentiate function. So that means that you are getting d square s by dt square. This is called second order differentiation. That is called second order differentiation. And next we will solve some problems based on the second order differentiation and how we can apply this to in our regular problems of physics. Regular problems of physics. So here I am giving a problem for the given displacement. The given displacement s is equal to 2t square plus 3t or 2t square plus t meters, where t is time. T is time. Then find the velocity and as well as acceleration. The question is find velocity and acceleration of the particle. Velocity and acceleration of the particle. First I want to calculate the velocity of the particle. The velocity of the particle v is equal to what we can able to write? ds upon dt. V is equal to what we can able to write? ds upon dt. That means v is equal to d by dt of s is nothing but 2t square plus t. S is nothing but 2t square plus t. If we are differentiating that, how much you are getting? Differentiation of 2 is constant 2 only. t square differentiation 2t plus t differentiation with respect to t with respect to t 1, x with respect to x 1, y with respect to y 1, but t with respect to t also 1. So that means v value how much you got? 4t plus 1. 4t plus 1, that is the velocity expression. And also they are asking about the acceleration. The acceleration a is equal to what we can able to write? dv upon dt. Acceleration a is equal to, we can write dv upon dt, that is d by dt of v value how much? 4t plus 1. V value, this value we have to take 4t plus 1. That means a value how much you can get? d by dt of 4t plus 1. So the differentiation of 4t is 4. The differentiation of 1 is constant function 0. So that means the velocity of the particle is 4t meter per second and the acceleration of the particle is 4 meter per second square. The meaning of that, the velocity of the particle is a time dependent. Time dependent means you can substitute t is equal to 0. What is the velocity? 1. You can substitute t is equal to 1. What is the velocity? 5 meter per second. You can substitute t is equal to 2. What is the velocity? 8 plus 1, 9 meter per second. And acceleration is time independent. Nothing but acceleration of the particle is remains constant and velocity of the particle is continuously changes. And let's see one more problem we are solving on this. One more problem. The displacement of the particle. The displacement of the particle. S is equal to t cube plus 2t square plus t meters. Then find the velocity and acceleration at t is equal to 2 seconds. At t is equal to 2 seconds. What is the velocity and accelerations at t is equal to 2 seconds? First you can try to get the velocity expression. Velocity v is equal to, what we can able to write? ds upon dt. Then v is equal to d by dt of s value t cube plus 2t square plus t meters. 2t cube plus 2t square plus t. So see here, differentiation of t cube 3t square. Differentiation of 2 into t square differentiation 2t, and differentiation of t is 1. So this is the velocity, and they are asking at what time? At a time of 2 seconds. At a time of 2 seconds. This value substitute there, then you can get v is equal to 3 into 2 square plus 2 into 2 plus 1, because t value only I am substituting. So that means how much you are getting? 3 into 2 square 4 plus 8 plus 1. So total how much you are getting? 12 plus 8, 20, 20 plus 1, 21. 21 meter per second. Then what about the acceleration? Acceleration is equal to what we can able to write? dv by dt. dv by dt. The a differentiation d by dt of, what is the v value? V value, this value 3t square plus 4t plus 1. 3t square 4t plus 1. Again differentiate that. Differentiation of 3 is constant. Differentiation of t square 2t plus differentiation of 4t is 4. Differentiation of 1 0. So then a is equal to how much you got? 60 plus 4. 60 plus 4, that is the acceleration. Now substitute the value of t. What is the value of t? T is equal to 2 seconds. So that is 6 into 2 plus 4. 6 2s are 12 plus 4. That is 16 meter per second square. After 2 seconds, the velocity of the particle is 21 meter per second and acceleration of the particle is 16 meter per second.